Okay, guys. Hello. Gonna be broadcasting the solutions to the Unit 3P practice test. Here we go. My name is Ramsey. It's probably gonna take about 4 parts to do this. So let's do the first part right now. It says the atom with the largest atomic radius, that's gonna be the one that's the most on the bottom left. That's gonna be magnesium. The atom with the highest first ionization energy, that's going to be on the top there. It's going to be sulfur. Do not worry about the noble gases. Here we go. The atom that is most likely to give up its electrons, another way of saying that is having the lowest ionization energy. That's going to be the one at the bottom left. So that's going to be magnesium. Once again, I apologize. This answer is rubidium. The atom that is most likely to form a molecule that has the formula XH4, you could substitute that with C. That works because carbon has 4 valence electrons. So the answer to 3 is D, to 4 is C. The answer to 1 is E, and the answer to 2 was A. The atom that contains 0 unpaired electrons, well, that's noble gases, and the only noble gas up there is argon, which is B. 5 valence electrons. We all know that nitrogen does that, so the answer is C. Okay, we see a bunch of structures. So quickly go through and do the Lewis structures. You might want to take a look at them and see if you can get them without doing that first. But since not everyone might know this instinctively, we're going to go ahead and draw the Lewis structures here. And CH4. So, contains double bonds and has linear geometry. That's going to be CO2. A. The molecule has trigonal planar geometry. 3 things with no lone pairs. That's going to be BF3, which is going to be B. The molecule has more pi bonds than sigma bonds. CO2 has 2 pi and 2 sigma. This one here has 2 pi and 1 sigma. So it's going to be N2, which is going to be D. The highest boiling point, that has to do with the intermolecular interactions. So we got London here, that's the lowest, get rid of that. We got London here, that's the lowest, get rid of that. We got London, lowest, get rid of that. London, lowest, and H, that's a hydrogen bond. So that's got the highest boiling point, NH3, so C. Following ionization energies. It's the ionization energies chart, just written a different way. So we're looking for the big jump, and the big jump happens between 2 and 3. So that is going to give you something that has a 2+ charge because it wants to lose 2 electrons, but not a third. That's a 0 charge plus, -1, 2+, there's your answer, and 3+. Alright, so you're going to have to draw a Lewis structure here. It's a little bit tricky. C, H, H, C with an O coming off it, and then an OH. So that's what it looks like. Okay, the Lewis structures of carbon. There is an sp2 carbon, and that's an sp3 carbon, so it's sp2 and sp3. So the answer is D, 2 and 3. That's an sp3 oxygen right there also. Okay, 13. Did I skip 12? No, 13. Order the following from highest to lowest with respect to their boiling points. So let's look at the intermolecular interactions. This is going to be London. This is going to be ionic due to the Ca. And this is going to be polar, covalent, no hydrogen bonding, so it's going to get dipole, dipole. Okay, so this is going to be first, second, third. They went from highest to lowest, so 2, 3, 1, C. Okay, consider C2H4 and C2H6. Alright, so we're going to have to draw the Lewis structures for each of those. C2H4 is going to look like this. And C2H6 is going to look like this. Okay, the carbon-to-carbon bond length in bond energy in C2H4 is greater than in C2H6. That's definitely true because that's a double bond. So that's a true statement. The carbon atoms in C2H4 are sp2 hybridized. That's definitely true. We have 1, 2, 3 things around it. That's true. Both molecules are nonpolar. That's also true. There's no lone pairs on any carbon. Which of the following gives you 109.5? So you look on page 64. 109.5 is tetrahedral. So we're looking for the one that's tetrahedral. And the only one in here that's tetrahedral after you do out all of these is CH4. So there's your answer to that one. Which of the following contains 2 sp2 hybridized atoms? That's going to be 3 things around it. After you do out the carbon atoms, after you do out the Lewis structures for all of these, you're going to see that in C, it's going to look like this. There is the sp2, and there is your sp2. In the rest of them, you're going to have carbon that has, there's at least one carbon that has 4 things around it, giving it sp3, and that's not what they're looking for. Which of the following will have the largest radius? So first of all, we know that largest radius is from top to bottom. So with F versus CL, CL is going to win. Okay, so let's get rid of all the F's. Now we know that minus is always bigger than the plus, minus bigger 0, which is bigger than the plus. So Cl minus is going to be your answer. It's going to have the largest radius. It's got more electrons, more shielded. Cl minus. Number 18, which of the following will have the smallest radius? Okay, so we know that radius increases this way. So between Ca versus Ba, Ca is going to have the smallest radius. So get rid of the Ba and the FRs actually. And we know that the plus is smaller than the neutral. So smallest radius is going to be Ca2 plus. It's got 2 less electrons. All of the following are nonpolar. When you do out the Lewis structures for each, you get this for H2S. Lone pairs push it into an asymmetric position, so the answer is C for that. When pH3 boils, okay, boiling is going from a liquid to a gas, and this is affecting the intermolecular, meaning you're going to have 2 pH3s, or moles and moles of pH3. But what we're talking about is the interconnection. So all we have is London, dipole-dipole, hydrogen, or ionic. So those are the only words we're going to look at. So there's ionic, polar covalent, that's not one of them. Hydrogen, okay. London, that's good. Dipole-dipole. Okay, so now we got to decide what it has here. It is polar, so get rid of London. There are no metals, so get rid of ionic. And there are no hydrogen bonding, because hydrogen is not connected to NOF. So the answer is E, dipole-dipole. Okay guys, I'm going to stop this video here and post a new one for the free response section.